Hi, welcome to notes number 15. We're going to be talking about comparing linear, exponential, and quadratic functions. So we're kind of connecting all of them. And really the big piece here is finding the average rate of change of each of these. So we're going to come back to that. So at the beginning of these notes, I want to review. We have three different kinds of functions: linear functions, exponential functions, and quadratic functions. So for each of these, I supplied you with right underneath each one. So that's what I want to, is we have y equals mx plus b, y equals ab to the x power, and then y equals ax squared plus bx plus c. So it is somewhat the parent function, but typically when we do transformations, the transformations go into each of these forms. Okay. So the first thing that we're going to do is plot the points and then tell whether the points appear to represent linear, exponential, or a quadratic function. So for A, go ahead and plot those points. Once you plot those points, go ahead and draw a line to connect your points. And when I connect these lines, it is going to make a parabola. Okay, and so you're going to have to tell me, well, a parabola is a quadratic function. So let's go ahead and fill that in. Okay, so for B, go ahead and plot those points. Once you create your points, go ahead and connect your dots. Now, for some reason, my straight line tool is not working, and so hopefully you guys are using a ruler, and you can create a better straight line than me. Okay, and so this function, when we have a straight line, it is called linear. Now, last one, go ahead and plot those points. And once you have these points plotted, go ahead and draw a line to connect these. And so hopefully you guys know, well, with this kind of function, this is exponential function, it will go in both directions. And on your left-hand side, it will go as close to the x-axis, but will not intersect the x-axis. It'll almost seem like it's running right alongside of it. So, but again, this is exponential. Okay. So exponential, we know that it will rise to the positive y values exponentially. It'll grow really, really fast. Okay, so let's go ahead down, and this part's pretty important, something that you should, highlight, make note of. Good tool to study. So we're going to talk about the differences and ratios of the functions. We're going to use patterns between the consecutive data pairs to determine which type of function models the data. Okay, so the differences of y values are called first differences. The differences in consecutive first differences are second differences, and I'll talk about that, what that means here in a second. So for linear functions, okay, the differences for your y values are constant. And the key thing, and you guys are really good about this, that when we talk about a linear function, it's a constant rate of change. So that rate of change that we always talk about, or the average rate of change, it is constant. With exponential functions, the y values all have that common ratio. That common ratio, remember, it's what you're multiplying by. Okay, sometimes you're multiplying by a positive 3, sometimes you're multiplying by a 1/3, okay? And then remember, the common ratio also plays into your geometric sequences. Now, lastly, we talk about a quadratic function. A quadratic function, the second differences are constant. Second differences are constant. And I'm going to show you what that means here. We're going to look at a quadratic function here real quick. So here we have our quadratic function, and then let's go ahead and take a look at the table for this quadratic function. And what I have on the notes is that it is the second differences that are constant. So I'm going to write up here real quick. For the second differences, we're going to talk about the change from 4 to 1 is 3. The change from 1 to 0 is 1. Change from 1 to 1. So we have, just writing down the differences here. 4 to 9 is 5, and 9 to 16 is 7, 16 to 25 is 9. And hopefully what you guys see is from 1 to 3, 3 to 5, 5 to 7, 7 to 9, okay, they each are changed by 2. So here they're increasing by 2 consecutive even numbers. That is, your second differences are constant. Okay. So on our second page, we're going to go ahead and take a look at these tables. The first thing I'm going to have you do is label each table. So we have number 1, number 2, and number 3. So that way when I'm talking, you guys know what I'm talking about. So we're going to write down what we notice about these 3 sets of data. Okay, so we have function number 1 that we'll talk about. And you know what I'm going to do is I'm going to just draw a line, and then we'll talk about function number 2. And then we'll talk about function number 3. So go ahead and put that in real quick. So for function number 1, we take a look at this table. When we take a look at this table, we see that it has when x is 0, y is 6. We see that on our x values, excuse me, everything is increasing by 1. On our y values, it seems like everything is increasing by 6. So let's go ahead and write in, let's say the y-intercept is 0, 6. And you know how we are saying our y values are increasing by 6? Can't we say that our slope is 6 at 6 over 1? So let's just go ahead. We'll use our good math vocabulary and say the slope is 6. Now function number 2. So for function number 2, again, when x is 0, y is 0, so we have points of intersection right there. It increases 14, 24, 30, actually, and then it goes to 32. And then it goes back down to 30. Okay, so we have, it's increasing on our y's, and then it starts to decrease. Let's go ahead and talk about how we have a maximum value. And really, when you are describing the sets of data, pretty much everything that I have talked about is fair game. Okay, you can go into quite a bit of detail or just about 2 sentences of good points. And then, you know, like I said, how we saw that the values increase and then decrease. We can write that down too. We can even talk about the intercepts, but I think I might run out of room. So again, the values increase and then decrease. Okay, sorry about the sloppy handwriting. Number 3. So if we take a look at number 3, again, we see our y value, our x values are increasing by 1. So we have that with all 3 functions. My y values, my h of x, here I go from 1 to 3, 3 to 9, 9 to 27, 27 to 81. Well, with all that work that we did with our exponential functions, I have an idea of what we have going on here. And so to get to each next y value, I'm multiplying by 3. So what we can say here is that it has a common ratio of 3. Okay, that means that we multiply by 3. So just a reminder what that common ratio means. It's multiplying. Okay, sometimes you multiply by a fraction. And then we can also put in that the y-intercept is 0, 1, just so we have 2 sentences to describe. Good. Okay, and then the next thing we're going to do is we are going to come up with the equation for each of these. So this is another reason why we had to label our tables. So we'll have function number 1. You like that change in black? Just, you know, smart boards like to be funny sometimes. Show me how smart they really are. And then function number 3. Okay, so for function number 1, remember that for a linear function, we use y equals mx plus b. Again, that's on the first page. Our slope is 6, and the y-intercept is 0, 6, which we wrote down in our description. So when we write our function, it's y equals 6x plus 6. Okay, or we can write it as f of x. Okay, since that's what's given to us for our y values, f of x is equal to 6x plus 6. For function number 2, this time it is g of x is equal to negative 2x squared plus 16x. How did I know that from just looking at that table? Well, I didn't. I used my graphing calculator. And so what I did with my graphing calculator is there's a place in there where there are lists and you can enter these tables. And then you use something, and I knew it was going to be a quadratic function. You use something called quadratic regression. I'm going to write that in there. I'm not going to be spending class time teaching you about how to use quadratic regression, but we're going to do something else that's very similar and kind of in the same area on your graphing calculator. So you can always go back and try this another time, or you can remember it, regression, sorry, ran out of room. You can remember this for your future math class and look really smart. Say, hey, are we going to use this? And then lastly, for our exponential function, we're going to remember, and again, this is on our first page, okay, right here, y equals ab to the x power. So when I create my function, okay, this time it is h of x. My common ratio was 3, okay, to the x power. Let's go ahead and talk about comparing functions using average rate of change. So for nonlinear functions, the average rate of change is not constant. Okay, so nonlinear functions, not constant. You can compare two nonlinear functions over the same interval using the average rates of change. Okay, average rate of change is a function between 2 points. Okay, so basically you're finding the slope of the line through 2 points. And so I write that in there for you, your formula. Average rate of change is the change of y over the change of x. I have f of b minus f of a. Remember, that's y minus y. Again, change in my y values. Okay, and this is all over b minus a, or your change in your x values. Okay, so let's go ahead and do our first example together. So we have f of x is equal to x squared plus 3. We're going to find its average rate of change from x equals negative 1 to x equals 3, and we're going to carefully show our work. So the way that we're going to do the work here is I'm going to substitute these values into my equation, come up with my y. So I'm going to start with y equals negative 1 squared plus 3. I'm doing my mental math. Okay, 1 squared is 1, 1 plus 3 is 4. Then doing this again, y equals 3 squared plus 3. Well, 9 plus 3 is 12. Okay, now I'm also going to show you how you can do this from your graphing calculator. So we are just going to come up with a table from our graphing calculator. Okay, so let's jump there real quick. So what I have is the equation in my graphing calculator, and I'm going to go ahead and go second table, and then I see the table of this function. And all I need to do is know when x is negative 1, y is 4, when x is 3, y is 12. So we can always just write this down in our notes. So let's go ahead and do that real quick. So just quickly creating my table. At -1, y is 4. We're going to skip some numbers. We're going to talk about how at x is 3, y is 12. Okay. Regardless, to come up with our rate of change, it's 12 minus 4 over 3 minus a -1, so it's 3 plus 1. It is 8 over 4, which is 2. Let's go ahead to our next example. So for our next example, this time I am giving you the table, okay? And so I give you the function, and you're going to find it over the interval from 2 to 6. So we'll go ahead and roll right in our slope. So I know from, remember how it's change of y over the change of x? Okay, so my change of x, it's 3, I'm sorry, it is 3, but it's 6. So from 2 to 6, our change is an increase of 4. And then looking at the y values from 9 to 3, it's an increase of 6. So when I go ahead and put this in, it's 6 over 4. Remember, change of y over the change of x. And that simplifies to 3/2, okay? And you can also write it as 1.5. Okay, just ran out of room over there. All right, and then the last one that we are going to do is I'm giving you 3 different functions in 3 different formats: the equation, the table, and the graph, okay? And so what we're going to be doing is we're going to order these functions from greatest to least by average rate of change over the interval from 0 to 3, okay? And so remember, the 0 to 3, we're going to focus on the x values. So same thing as I did before. I'm going to go ahead and divide my paper into thirds. I'm going to talk about g of x first. So for g of x, they give us an equation. One thing you can do is you can substitute all of this into the equation, or we can go to the graphing calculator. And let's go ahead and do that. So here's my function in the graphing calculator, and you can follow along with your own. And then I'm going to go to the table. And so what I'm focused on is that rate of change from 0 to 3. And so I have my values, and I'm going to put these values in a table on my notes. So what that's going to look like, I have my, I must have clicked on the wrong thing. So let's fix that real quick. I wanted blue. Here's my blue. X, Y for my table. When x was 0, y was 0. We're going to jump to 3. When x is 3, my y is 3. And so for each of these, my rate of change, so when I kind of do my math here, my rate of change of y over the change of x, okay, it's 3 over 3, which simplifies to 1. Let's go ahead and take a look at my next function. My next function is f of x. Okay, I know it's f of x because of right here. And so we are looking for the interval from 0 to 3, and that's an increase of 3. And so when x is 0, y is 1. When x is 3, y is 7, and an increase of 6 over here. So when I figure out my slope, remember, change of y over the change of x, okay, it's 6 over 3, and that simplifies to 2. I don't think I stress this. Always write your rate of change in simplified form. And then the last one is going to be my h of x. Okay, so again, I get h of x right here. It's talking about the graph. And so for my graph, I'm going to just make another table. Okay. Put my parentheses in the wrong spot. There we go. So when we're doing from when x is 0 and then when x is 3. So I already know I'm going to have a change of 3 here. So when I look at my graph, when x is 0, y is 2. So I'm going to put that in. When x is 3, y is 9. So there's that value. So I'm going to put that in. And my change here is an increase of 7. Again, when I try and figure out my slope, my average rate of change here, it's 7 over 3. I'm going to simplify it so I can compare it better. I have 2 1/3. And then the very last thing that we are going to do is write this in order from greatest to least. That's what I underlined. So h of x is my greatest, f of x is my next greatest, and then g of x is my least. Okay, so this is my final answer for this last problem, again, in order from greatest to least. Okay, and that's it. See you next time.